Sudah tak dengar lah.
Saya tak on mic, tak dengar. Yeah. Okay. Dengar? So now you have separately excited DC motor. So you'll have two separate circuit. One is for armature windings and the other one is for field windings. Okay, so basically its performance the same as the shunt motor. So the difference is the shunt motor, the field winding is connected to the terminal voltage, but this one you have a separate. The field winding is separately excited, which means that you need to have additional external DC supply to supply for the DC field winding. And this type of windings motor is only for special cases, such as when you need a wide variation of terminal voltage. So maksudnya, like say if you need a wide range of terminal voltage, but if you're using a shunt motor, so the field winding basically is limited to certain amount of voltage, because if we go beyond that value, so you might damage the windings, sebab dia mungkin akan ada damage, akan ada flash over antara turns of the winding. So that's why we need to separate the field winding from the terminal voltage. So let's say here for the terminal voltage you need from 0 to let's say 600 V, but this field winding is only capable to cater you from 0 to 300 volts sahaja. So this one you need to separate it. Okay, or when you have to control or the field current is necessary, so you need to macam kita part of the controls, machine control, so you need to control the field current, sama ada kita nak pergi ke read, dia panggil field weakening control, kita nak melemahkan field so that the machine will rotate at a very higher speed. So the disadvantage of this type of connection, it needs a separate source of direct current to supply the DC, the field winding. So itu dia. The performance dia adalah sama macam a shunt motor. Okay, so this is the power flow of the DC machine. So there's a difference between DC motor and generator, whereby for the DC motor, the electrical power is the input. For the DC motor, the electrical power is the input. Why? For the DC generator, mechanical power is the input. Okay. And before this input power, electrical power is transformed into the mechanical power ataupun peak output ataupun useful power, useful mechanical power yang boleh digunakan lah untuk rotate something. So the losses, the power ni akan mengalami kehilangan, maksudnya akan ada losses lah. So disebabkan oleh you have your winding ataupun winding, lepas tu ada I square R losses. So this is basically for the winding lah, and the conductor, so akan ada I square R losses. So ini dekat mana? Dekat your field winding plus armature winding, kan? So mana winding dia akan masuk dalam kategori IR square losses. And then lepas tu semua, this is the area we panggil dekat air gap tau. Dia transfer daripada mechanical to electrical to the mechanical. So you have the akan ada induced torque tau induced dengan rotation omega m, mechanical speed. And then you will have the core loss sebab the machine pun ada core kan. So the core disebabkan oleh silicon steel atau laminated sheet of laminated iron yang buat rotor dengan stator. Lepas tu awak akan ada mechanical losses ni, anything yang relates to the mechanical macam movement, you have a bearing ataupun losses daripada segi rintangan angin dalam motor. So that's we call it as a windage, friction and windage. Yes, friction and windage losses. So that's mechanical losses. And so brush losses pun sama dalam ni juga. And you have the core losses disebabkan oleh the material. Awak ada hysteresis dan juga eddy current losses dekat core. And you have mechanical losses. Those three losses ni adalah losses yang kita tak boleh nak kelaskan dia dalam mana-mana kategori, sama ada brush atau core atau mechanical. So you still have the losses tapi tak tahu kita nak classify dia dekat mana. Then we call it as a stray lah, stray. So anything can be happen lah, maksudnya stray mana-mana lah. But still, so basically conventionally the stray losses is taken by only 1% of the full load. Okay. Alright. So for the DC generator terbalik pula, you see, this is macam kalau kita tengok, this is a part of the different of the motor. So generator kita perlukan the P input adalah daripada applied torque dan juga mechanical rotation. So you need to have prime mover, prime mover to move the rotor. So prime mover ni dia work pada mana-mana lah, anything lah, maksudnya macam apa yang boleh memusingkan dia lah, macam angin, macam hydro, daripada blade, daripada turbine, hydro turbine ke gas turbine ke wind turbine ke anything. Then dia akan pergi kepada stray losses dulu, lepas tu akan ada mechanical losses, and then you have core losses. Lepas tu dekat this point the P conversion ni, maksudnya daripada P conversion tu dia besar ke? Kalau P conversion ni, sama juga ni pun, maksudnya P conversion dia convert daripada the generator daripada electrical into generator from mechanical into electrical. And then you will have the conductor losses, I square losses. Lepas tu baru dapat dengan your useful electrical power. So sama juga dengan DC motor, the power conversion means from the electrical power dia nak convert kepada mechanical power. The remaining power is ideally converted from mechanical to electrical at the point labeled as P conversion. Then you will experience the electrical and brushes losses, dan juga the remaining electrical power is output to the load. So this is where useful power. So that's the difference between the power flow between DC motor and DC generator. So as for the efficiency of the machine, so ini saya rasa belajar mana kan. So for DC machine, right. So efficiency output bahagi input times 100. So itu biasalah. That's the ni awak tahu kan, sistem standard punya calculation. Okay, dekat machine apa yang terlibat dalam the losses. So for example in a shunt motor, so you have the armature losses of course, and you will have the field winding losses, dan juga C ni adalah it's the sum of iron friction and windage losses. So sebab things yang kita boleh measure adalah I square R, and this is the losses for the field, dan iron losses also can be measured, cuma friction and windage ni kita nak directly measure agak tak boleh, so we need to minus from somewhere, from the total power. So you minus all the losses that you have measured, then you will get this friction and windage losses. Okay. So the input power is VI. So the output power will be VI minus losses. This is the losses. Hence the efficiency will be this V, the power input, the output power minus the output power, the losses, and divided by the input, then you will get 100% times 100%, so you get efficiency. So from here we can find the maximum efficiency. So from this equation it shows that the maximum efficiency of the machine can be achieved when I square R is equals to IFV plus C. So apa maksud dia? Bila you have your so bila you have this, kalau kita gantikan balik maksudnya, the losses you have is only bila I square R is equals to IFV. So this is the maximum efficiency lah. Bila kita buat DI, DV, DV, bila kita buat you want to have the maximum, so kita dibahagi dengan sorry, this is max. D apa nama dia, D zeta bahagi dengan dVi kot, dVi, so we get 1 1. This is the equation of the condition where you can have your maximum running at maximum, your machine running at maximum frequency. Okay, so this is example number 5. So this one, you're looking for the overall efficiency of the motor. So you can see here is given the friction, windage and losses amount to, so this is all together, the C plus friction plus dengan windage losses. Tanya pada determine the overall efficiency. So what is the P in, power input of the machine? So P in will be the power input is equals to VI. So V is 320 times 80. So you get so straightforward, 320 times 80, so you get 26,000, 26, 25 600,000 watt power kan watt. So your losses sekarang ni kita guna apa? Kita perlukan you have this and this and this, so you need the conductor losses, the copper losses. So you need to find the I square R dan juga the field resistance. So juga so I square R means kalau awak tengok your shunt machine will be like this. So you need to visualize how the shunt machine. Okay, so this is your VT 320 and the machine is direction. This is your IA. So this is your IF and your VF of course will be equals to VT. So IA, now IA times the RA I square, the losses will be 80 square times the 0.2 ohms. So 80 times 0.2, so you get about 1280 watt. Okay, and now you still have the conductor losses, which is the shunt, which is equals to IFV. So the IF, how much is your IF? You don't know your IF. So basically we can find the IF by IF sama dengan V divided by RF. So your V is 320 divided by field resistance is 40. So 320 divided by 40, so you'll get about 8 ampere. Then your IF VF is equals to 320, which is equals to sama so 320 times 8 dapat 2560. So now your efficiency of this machine is equals to the P in is 25,600. So minus all the losses that you have, 1280, this one, and plus dengan 2560 and plus dengan 1500 watt. So divided by the input 600. So you will get a lebih kurang, so 25,600 minus 12080 minus 2560 minus 1500, so divided by 25,600. So your machine times 100, so you will get percent. So the efficiency of the machine is about this much, the 79.1%. So number 2, a series motor draws current. This is series motor. So the armature resistance of the series is of the motor, the armature 0.15 ohms, and the field resistance is 0.05 ohms. Determine the maximum efficiency of the motor. So now it is given that you have the armature resistance and the field resistance. So dekat sini senang je. Your P input, okay, VI. So the losses dia bagi variable S square. So dia bagi now the losses untuk the losses P losses P copper losses sebab series kan, P copper losses conductor lah, equals to I square IA square. So R in series you can tambah terus 0.19 15 campur dengan 0.05. So 0.15 campur 0.05 darab dengan 40 ampere darab 40 ampere. So lebih kurang 320 watt. And the power input adalah 250 darab PVI 10,000. 10,000 watt output. Okay, so the maximum efficiency, kita tahu maximum efficiency is when your the efficiency of the machine adalah sama dengan VI tadi minus your IA square R minus C minus friction minus dengan windage kan. So bahagi dengan VI. Okay. So for the maximum efficiency, I square R sama dengan C campur friction campur windage. C pula. C dah masuk semua kan? Sorry, IFV minus C. This one. Saya silap C. Ini C dah campur semua. So maximum is when IFV campur C. So macam mana tu? Equation kita kat sini minus this one and minus this one and minus this one. So kalau kita consider ini sama dengan ini, macam mana tu? Apa akan berlaku? So kalau awak tengok IF dengan V, sebab kita kira sekali tau, kita dah consider sekali at the losses dekat field, maksudnya losses dekat sekejap je, kita asingkan dah, kita asingkan balik. Saya asingkan balik P PCURA. So ada dapat 40 kuasa 2 darab dengan 0.15. So you have 240 watt. So P untuk field RF 40 kuasa 2.05 80. So basically yang ini apa dia R ni R A. So dekat sini maksudnya dia akan jadi 10,000 minus kita samakan dulu. Maksudnya sama 2 I A bahagi dengan C30,000. Betul tak? Kan? Sebab ini sama dengan ni kan. This one equal to this one kan. So we dapatlah bagi 1,000. So you get the 320.2. So 10,000 minus 320 minus 320 bahagi dengan 10,000. So you get 90 kali 100. So you get 93.6%. Just replace this ini dengan ini. So you have calculate this one is this one. Kan, dah calculate ya. So 2 darab ni sekian-sekian dapat lah. Okay. So for the DC motor starter, macam mana kita nak start DC motor? The method. So to run the machine run the motor from stationary, from directly power supply, most likely will burn the protecting fuse of the motor. Sebab apa? Because of the starting current is very huge, it's very high. So sebab dia kata it is because the armature resistance is small and frequency being less than 1 ohm frequently. Sebab because of the resistance is small, so the current akan banyak lah kan. So itu yang will burn the protective fuse. Kalau dipanggil DOL kan, direct online kan, DOL. So it's very high current, you need to have a very different protection lah, very huge. Maksudnya fuse tu kita boleh calculate sebab untuk starting current ni dia most likely lebih kurang 8 hingga 11 times of the rated current. So let's say your rated current, armature current is 40 amp, tapi the starting dia akan pergi up to 8 hingga 11 kali ganda. So imagine how big the current will be. So you need to have very huge protective punya fuse, dan dia boleh menyebabkan increase in terms of cost lah. Awak kena beli yang higher rating. Sepatutnya you can use small rating, but because of this you need to use higher rating, so the cost will be increased. So how to overcome this? Kita akan ada starting macam ni, by fuse. So maksudnya biasa kalau dekat lab nanti pun masa starting kita akan letak the starting resistor tu pada maximum value, supaya kita dapat perlahan limit the current, reduce the current. And then once kita dah start, motor dah start bergerak, berpusing, then gradually kita akan reduce the resistor, starting resistor sampailah kosong. Okay, so to overcome this, you need to have additional resistance must be added to the armature circuit at the instant of closing the switch to the start motor. Maksudnya bila kita nak start motor tu, kita kena add armature lah dekat armature switch, dekat armature resistance. As the speed of the motor increases, the armature conductor are cutting flux and generate voltage. Acting in opposition to the applied voltage, it is produced, which limit the flow of the armature current. Okay, then the additional armature current resistance is reduced. At normal running speed, the generated EMF is such that no additional resistance is required in the armature resistance. So this one kita kena reduce lah. To achieve this varying resistance in the armature circuit on starting DC motor starter is used as shown. So this is the reason this is the reason macam mana we need to use the DC motor starter. Untuk DC starter, semua kita pakai DC motor starter. Ni Shan motor, semua pakai. Okay, tu masalah dia. So this is all the ni. Alright, saya rasa kita kita buat tutorial yang minggu, yang hari apa itu? Hari Selasa kan?
Selasa.
Betul tak? Selasa. So kita sambung, kalau boleh kita sambung untuk hari Selasa tu. Kita buat yang nombor 2 punya, yang motor. Saya ada hantar dekat WhatsApp tu satu additional file graph yang awak perlukan untuk macam saya nak buka buka kita semua. Aku dapat reader. Okay, so ini yang generator dan kita akan buat untuk motor. Okay, so for DC motor dekat sini, you have based on figure 1, if the adjustable resistor conteng. Alright, if the adjustable resistor is adjusted to 175 ohms, so what will be the what is the rotational speed of the motor at no load condition? So you know macam mana nak dapatkan the speed the speed of the motor. So how to relate this? Basically untuk DC machine, you know that the back EMF okay, the back conteng okay, the back EMF is equals to saya kena buka ni. Saya stop sharing balik, so saya share. Saya kena share all. Saya kena share screen is better. Okay. Macam mana? Tak boleh, saya stop sharing. So saya share content or share screen. Tak keluar. Okay. So this is the okay. Okay. So question number 1 kata if adjustable is adjusted to 175 ohms, what is the rotational speed of the motor at no load condition? Jawapan dia dah ada. So kalau awak tengok apa kaitan dia, you have your E is equals to K V N. So ini memang you should know lah the equation, the back EMF EA, dia maca back EMF. Alright, so bila dia kata are adjusted at 175, so maksudnya dekat sini kita kena dia kata the variable resistor tu berada dekat field kan, dekat field circuit. So you have to find how much is EA based on the equation of for the motor EA VT minus IA RA. Kan? So your IF is equals to VT bahagi dengan RF plus R adjustable. So dekat sini your IF will be equals to your VF is 240 divided by your RF is 75 plus 175. So basically you will get your 0.2 45 plus 175. So 240 divided by 250, and then you will get 240 divided by 250. So it's equivalent to 0.96 ampere. Okay, pada keadaan ini, this condition. So now your what is your IA? Your EA equals to 240 minus what is your IA? IA sama dengan apa? Ada benda yang kurang ni. So okay, tak perlu cari IA. No need. Sebab apa? Cukup dapatkan IF and then kita boleh refer pada curve yang tadi. So nanti kita refer kepada IF, it says E. Okay. So the curve will be something like this. So ini adalah dia panggil the characteristic of back EMF against field current. So benda ni biasanya dia akan, kalau awak beli mesin yang besar, yang patut untuk pump yang besar lah, dia akan provide benda ni lah, dia punya testing dia test pada certain speed. So this machine has been tested at the speed of 1200 RPM. So there is additional information pasal bullet ni, saya rasa kita sebab ada tak lengkap ni. Kejap saya tengok balik. Saya tak lengkap, ada kurang sekali. Information cukup dari segi untuk for the machine this one. Okay. Saya bagi kat lagi. Alright, so kalau awak tengok dekat this curve, awak nampak this curve has been tested, is obtained when the machine is running at speed of 1200 rpm. Yeah. So from this curve, awak tengok you get the 0.96 of field current. So when we refer to this curve, so at about this, ada kuning pula. So at about this, okay, 0.9 okay, pada this point, macam mana saya nak buat ni? Tidak. Okay, so at this point 0.96, okay, 0.96. So your generated back EMF is about, dekat sini aku buat pembaris awak try buat, saya tak tahu dah nak lukis macam mana dalam ni. So kalau kita tengok dia punya solution dia pada 0.96 IF, your generated voltage will be, contoh dekat sini kan, dekat sini your IF is 0.96, so your EA will be equals to 277 V from that figure tadi. So now you have to relate this condition dengan apa yang teacher yang perlu dicari, apa yang nak dicari oleh apa yang questions want you to find. So from this equation, from this relation, awak ada the EA, let's say you have the old value and then equals to, ni sama kan, just n old value, so you divide it dengan EA new value and new. So what is old? Old ni adalah all the data from here, okay, because you are looking for a new value. And so at no load, ingat soalan kata at no load kan, so saya tambah additional kat sini, at no load, kalau awak tengok kat circuit tu, the IA must be equals to 0 lah. Tak ada current flow kan, so there's no current flows, maksudnya the IA will be equals to 0. So pada keadaan no load, your EA is equals to VT from this. So now your old value is 277V, your old speed is 1200 RPM, bahagi dengan EA new is 240, and the new awak tak tahu. So now your speed new is equals to
Betul.
240 divided by 277 times dengan 1200. So 240 divided by 77 times 1000. So your speed at no load is equals to 040 rpm. So therefore your speed at no load is 1040 rpm. Okay. Macam mana kita dapat ini? Sebab from here, bila kita bahagikan, K dengan flux sama. So we can cancel this. So now you have the left adalah EA dengan KN sahaja. Okay, nombor 2. Nombor 2 dia tanya nombor 2 dia tanya, assuming no armature reaction, what is the speed of the motor at full load? What is the speed regulation? No armature reaction. Armature reaction saya dah beritahu awak. Kan? Saya dah explain no armature reaction. Did I? Saya explain kan what is the armature reaction kan? Okay. So, assuming no armature reaction, maksudnya kita boleh pakai the calculated IF tu tanpa perlu mencari the effective field current. So assuming no armature reaction, what is the speed on the full load? What is the speed regulation of the motor? So at full load, not at full load, at full load, okay, at full load, it is given that your IL at full load rated kat sini equals to 110 ampere. So yang ini kan awak boleh pergi ke yang saya bagi tu textbook tu, textbook tu muka surat muka surat to exercise muka surat dekat problem, muka surat problems dia alright, so muka surat 553. So you see at the e-textbook saya bagi tu, yang bahagian DC machine tu, page 553. So dekat situ ada information on the, tengok problems yang problems 8.1 tu. So awak tengok dekat situ dia kata all those information pasal machine. The power rated is 300 HP, VT 240, and rated, the speed rated is 100. So ini salah, ini lain sikit lah. The speed 100 is here is 100, 1200. So not this one. And apa yang beza dia? Dia dekat sini bezanya hanya pada dekat rated speed dekat sini, yang dalam your tutorial is 1200. So here is 1800. So awak tukar yang ini ke 1200. Yang lain sama-sama. Okay. Okay, so IL is equals to 110 is the load current at full load. So your soalan is, what is the speed of the motor at full load? So what we can do here, at first, so it is given that there is no armature reaction. So at full load, the armature current will be how much? So at full load, tengok tadi dekat circuit dia kan. So definitely IA, so IL is equals to IA plus IFL, and then your IA is equals to 110 minus IF is 0.96. So this is equals to 219. So this is equals to 109 ampere. So at 109 ampere kita dapat the IA. So bila dapat IA at this full load, so you need to find the EA is equals to VT minus IA RA. So this is equals to 240 minus 109 times 0.19. So you will get 209.3 V. Alright, so you have your old value just now, kan? Now we are looking for the new value at a full load. So you have your EA old bagi dengan EA new, the speed, the old speed, and bagi dengan new speed. Then so from here we are looking for the new speed. So and new, your old is EA new is 219.3 divided by, this is from the curve, from the curve to 77 at 1200 pada at the curve lah, at the reference at the curve pada no load speed. So from here you darab, so you will get 950 RPM. So maksudnya so this is your full load speed is equals to 950 RPM. Right. So what is the speed regulation? The speed regulation menunjukkan bahawa julat yang awak boleh, yang mesin tu boleh the rotational speed of the machine berada, maksudnya the speed regulation, the range of your DC motor speed when it has when the so this is the range of your speed to show that the range of your speed in percentage when your machine is loaded at full load. So it's between no load and full load. So how big is the range though? How much you can, the machine can the speed of the machine can be varied from the no load to the full load. So if the machine goes beyond that the speed regulation ni, maksudnya kalau dia rotates higher than 1040, so there must be a problem with the machine lah. And kalau the speed regulation ni rendah daripada 950, so there also must be a problem with the machine. So yang ini akan menentukan dipanggil nanti kalau kita design the protection of the machine, so kita nak pastikan that machine tu the sensor yang measure the rotation machine tu dia beroperasi pada this range. Kalau keluar this range, so dia akan trigger something might happen machine. Contohnya mungkin kita tahu mungkin the wire dia terlalu satu, mungkin the load itself tu terlalu berat menyebabkan the motor tak boleh nak gerak dan sangat, atau mungkin ada winding short, so ada benda tak kena lah. So maksudnya benda ni dia akan trigger kita lah kalau it goes beyond that. We have to calculate the speed regulation, dan juga speed regulation ni pun kita boleh control. Maksudnya untuk letak resistor apa semua, so kita boleh control the speed within this range. Sebab kalau it goes beyond this range, it will be no longer efficient. So the speed regulation sama je macam macam kita nak kira efficiency, cuma dekat sini dia speed lah. So you have your speed at full load minus speed at no load bagi dengan speed at full load times 100. So at speed at no load, this is full load, this is no load. So no load is 1040. Bila dia full load, dia berat sikit kan, full load kan, so the speed must be less and divided by no load times 100, so it equivalent to 9.5%. So this is the range of your speed can be played with 9.5%. So when we go for the question number 3, dia kata if the motor is operating at full load and if its variable resistance RA are adjustable, is adjusted to 250 ohms, what is the new speed of the motor? Okay, so apa sebenarnya berlaku ni? So maksudnya the machine running kat full load, lepas tu kita tukar adjustable tadi, maksudnya kita bila kita increase to 250 ohm, maksudnya kita mengurangkan I field. Kita tengok data tadi bila kita adjustable kan, so bila kita increase dia, maksudnya kita mengurangkan IF, kita turunkan IF. So bila turunkan IF, you will get a new IA. So basically bila you turunkan IF, so you have a new IF 240 masih lagi. So your IA 250 plus 75, so you get 240 divided by 250. So your new value of field current is 0.736, and this you need to find a new EA. So now you look into the curve and you find the EA, which is equals to equals to 256 volts. Pada dekat curve tu. Okey, tapi pada masa ni motor masih lagi running at full load. Maksudnya pada kadar RA yang sama. Maksudnya pada full load tu maksudnya the machine is running at full load. The current is at full load, so you need to find bila kita kurangkan air fill, so definitely the speed akan sama ada increase atau decrease lah. Mungkin dia akan decrease, dia akan increase atau decrease bergantung kepada speed tadi, kepada air fill tadi. Pada awalnya your machine running at 950 RPM. Okay. Lepas tu dia kata are adjustable need so that your field current is reduced by a certain amount to 0.73 ampere. And then to find the new speed of the machine is running now, you need to find EA dekat curve dulu, and then kita boleh calculate balik to find the new speed. So this value from the curve is when the machine is rated at 1200 running. So now the machine still is at full load, maksudnya your EA at full load is still the same. Your EA you have your old here equals to an old, so bahagi your new bahagi and new. So which one is old, which one is new? Sama juga. Yang old ni adalah from the curve. So that's the old. So you have to find new speed. So which is so you have to so 219.3 divided by 2556 times 1200 RPM. So your speed will be 1028 RPM. So this is your new full load speed when, so this is your new full load speed when R adjustable is reduced from 0.96 from 175 is increased from 1795 to 250 ohms. Sebab pada 075 ni your no load speed is 950 RPM. So bila kita increase the R adjustable to this one, so 251, bila you increase it, maksudnya the new speed when R adjustable is increased from to subsequently the IF is reduce from 0.95 to 0.739 ampere. So you see, so ini dia punya statement dia. Maksudnya you have a new float speed bila your IF is reduced from something value to a new value. Okay. Tapi the machine, yeah, of course, the machine is still running at a full load. A full load means yeah, full load. IL is equals to 110. Okay. Alright. Okay.
So yang 219.3 tu mana Sir.
Okay, so now just look at include the armature just look kita include the armature reaction. Okay, result Q2. So to include the armature reaction, you need to find new IF. So which is equals to your effective IF. So your IF minus and here is the ampere turn atau the armature reaction PAR bahagi dengan number of turns, the turns NF, the field number of field turns. So this one dia kata berkait dengan question number 3. So at this one you need to find 0.96. So minus dia kata di armature reaction dia 1200 ampere per turn bahagi dengan 2700. So the armature reaction is betul tak resistance saya? Alright, so dekat soalan tu dia bagi the armature reaction is 1200 ampere turns. So now you have to find new IF, effective IF, so which is equals to 16 ampere. So from here you look into curve and then see curve CURVE and then CURVE and then you can find the EA which is equals to 210 V. So the same, we apply the same formula. Okay, so we apply this formula, so you get your speed I see. So your NU is equals to E new bagi dengan EO times dengan NO. And so your new is 219.3 bagi O, saya cakap O daripada curve kan, 210 the speed daripada curve. So now your speed is 1253 RPM. So maksudnya pada keadaan ini your generated voltage is Besar. Your generated voltage JE is 210, which is less than the generated EMF at full load. So kalau kita consider the armature reaction dalam real life pun memang akan ada armature reaction. So the speed, your full load speed will be 1253. So this means bila kita consider the armature reaction, the machine will rotate at higher speed. So maksudnya the speed of the motor bila kita consider armature reaction is running at much bigger than the speed when we consider no armature reaction. So sebab apa? Dan justifikasi dia adalah this we have calculated just now. This one when we consider the armature reaction, and this one when we did not consider the armature reaction. Okay. Lepas tu soalan last sekali kan, if R adjustable can be adjusted from 100 to 400 ohms, what are the maximum and minimum no load speed possible in this motor? So ini sama je lah. Ini sama lah. You can find when you, so at first you have to find the IF. So this one ni nombor berapa lah? Ini nombor 5 kan? So for the question number 5, at first you find the IF when at RADJ is equals to 100, and then you find the IF at RADJ is equals to 400. So from here you got the IF, dapat IF, so look into curve, then curve, so you find your EA, then you apply the same rule as this one, the same rules. Apply the same rules, E all, N all, E new, N new. Then dapatlah dah cari dia punya N new berapa. Ada tadi no load speed. So no load speed maksudnya this one, so new, so E new at no load adalah 240 kan. So soalan dia tanya pada keadaan no load, what will be the range of speed if the adjustable is adjusted to 100 to 400. So the same rules apply, then you will get the answer as printed dekat jawapan. Saya rasa dia tak ada problem sangat. At number 6, what is the starting current? What is the starting current of this motor if it is started by connecting directly to the power supply VT? And how does the starting current compare to the full load current of the motor? So yang kita dekat slide tadi, what will happen bila kita start motor directly from the source without installing the starting resistor. Okay. So dekat sini we can see the answer. So apa dia kata, what is the starting current of this machine? It is stated by connecting it directly to power supply VT. How does the starting current compare to the full load current of the motor? So the starting current of this machine, when we ignore the small field current, so basically we can go directly number 6. Maksudnya secara mudahnya untuk calculate the starting current. So the starting current basically will lead to the IL lah kan, IL the starting current. So kita boleh ignore, so kita boleh approximately IL is equals to IA. Ini untuk shunt, sama juga untuk series lagi direct kan, IL sama dengan IA kan. Okay, so when we ignore the small field current buat 0 point something ke small lah, and then we can calculate this the starting current directly. So 240 bahagi dengan resistance dia, so you will get 1000 ampere. So this is very huge. So this is a very huge amount of current. So macam ni awak punya fuse awak macam mana, and protection awak kan, mesti dia dah blow ke, dah trip sebagainya lah. 1000 agak tinggi. So it almost your full load current is your rated current, your rated current adalah 110. So it more than, so this is your IL full load. So the starting current ni I start awak adalah more than 10 times of rated current. Betul. Kalau kali 10 baru 1100. So this is more than 10 times. Sangat besar lah. So dekat sini dia kata it's about 11.5 times greater to the full load current. So this much current is extremely likely to damage the motor. So this is memang damage motor kat lagi. Dia burn the windings. So tanya protection kali. So that is the solution to today. So ada soalan. Saya ini kalau rasa jawapan lalu baik your friend. So kalau dia selesai dan dia jawapan dan betul. Alright. So I think verification. So let's on week 99. Misalnya so you have to one because after break you will have test. Saya tiga session dan we do it all together. Mungkin kalau saya jam ni lain. So mostly kita akan buat malam semua malam. Okay. Malam. Saya buat malam ada mungkin kita akan buat Friday atau Friday tentang malam. Pulang balik dengan lain. Okay. So ada soalan. dia mendapat EA pun. Ya, tengok boleh banyak kelakar tu. Tengok berarti dia I fit jawab sekali tu is equal to 0.996. So tengok kelakar tu. Dapat lagi. Yo. Dekat social media tu orang lelaki orang dapat buat poin sama-sama. With 99. Not sebab you rendah again. Dengan seks itu lebih juga. Dan sendiri. So to be exact, dia kalau awak skill kan awak, the test will be on DC machine lah. DC machine. So kehadiran will record. Ni yang saya tengok balik. Boleh cari. Okay, this one saya alright. Saya akan tengok balik. Okay, right, itu je kot. So kalau tak ada apa-apa, kita end our session here. So jumpa lagi pada minggu ke-9 lah. Next week cuti kan? Alright, so okay, bye. Salam Jumaat. Dan semua boleh pergi makan. Okay, first. Okay. So I stop sharing sekarang. Okay. Alright. So okay, alright, okay, bye. Assalamualaikum.